A fully loaded semi-truck rolling downhill at highway speed weighs as much as 45 average cars stacked on top of each other. And at that moment, the driver is not pressing the brakes. He is using a system of gears so precisely sequenced that the engine itself becomes the brake. So here is the question that should have bothered you every time one of those trucks rumbled past you on the highway. Why does it take 18 gears to move something forward? Most people assume the answer is simple. More gears equal more power. That is the intuition, and it is completely reasonable. You have probably noticed that when you are riding a bicycle uphill, you shift to a lower gear, and it gets easier to pedal. And when you are going fast on a flat road, you shift to a high gear, and you cover more distance per rotation. 18 gears then, it must just be a bigger version of that logic. More range, more flexibility, more grunt. The engine needs options, and 18 gives it plenty of them. That reasoning is entirely correct in principle, and completely misses the point of why the number is exactly 18 and not 8, or 12, or 30. Here is the number that will stop you cold. A fully loaded 18-wheeler can weigh up to 80,000 pounds in the United States. That is the legal limit on federal highways. 80,000 pounds is roughly the same as 14 full-grown African elephants, and the engine driving all of that weight is, in engineering terms, absurdly small for the job. A diesel truck engine typically produces somewhere between 400 and 600 horsepower. Meanwhile, as a commercial passenger jet produces the equivalent of roughly 100,000 horsepower per engine. The truck is moving the weight of 14 elephants with a fraction of the muscle. The only reason that works at all is because of what the transmission does to that power before it ever reaches the wheels. This is what nobody tells you. The gears are not there to give the driver options. They are there because of a law of physics that the engine cannot escape. And it is the same law that makes it impossible for you to open a jar of pickles with 2 fingers. That law is called torque, and it is completely different from power, even though people use those words interchangeably. Power is how much work you can do in a given time. Torque is the rotational force that gets the work started in the first place. A big diesel engine produces enormous torque, but only within a very narrow band of engine speed. If you rev that engine too low, it stalls. If you rev it too high, it overshoots the torque's peak and starts losing efficiency fast. The sweet spot, the range where the engine is actually doing its job at full capacity, is only a few hundred revolutions per minute wide. That is almost nothing. A typical diesel truck engine produces peak torque somewhere between 1,100 and 1,500 revolutions per minute. The entire efficient operating range might span from roughly 900 to 2,000. Outside of that band, the engine is essentially wasting fuel and wearing itself out. The gearbox exists for one purpose only: to keep the engine inside that narrow window no matter what the truck is doing on the road. And here is where the 18 comes from. When a truck starts from a dead stop with 80,000 pounds behind it, the wheels need to turn very slowly while the engine is still spinning at its efficient speed. The gear ratio translating engine rotation into wheel rotation has to be enormous, sometimes as large as 14:1 in the lowest gear. 14 engine rotations for every single wheel rotation. That is what gives you enough mechanical advantage to get 14 elephants moving from a standstill. But once the truck reaches highway speed, running at that same enormous ratio would have the engine screaming at 60,000 revolutions per minute, which would destroy it instantly. So the transmission progressively flattens that ratio as speed increases, through second gear, third, fourth, all the way up to a top ratio that might be less than 1:1, meaning the wheels spin faster than the engine. Between those two extremes, you need enough intermediate steps that the engine never has to leave its efficient window during the shift. Too few gears and you create gaps, moments where the engine drops out of its torque band and the truck loses momentum. On flat ground, that is inconvenient. On a mountain grade with 40 tons behind you, it means you stop. You need exactly enough gears to make the climb through the speed range seamless, and for the physics of diesel engines and the speed ranges of real highways, that number works out to 18. The story of how we arrived at 18 specifically runs through a particular problem that appeared in the 1940s and 50s. That when the American highway system was being designed and trucks were getting dramatically heavier to serve post-war industrial demand. Early trucks used simple 4- and 5-speed transmissions borrowed from agricultural machinery and early automobiles. Drivers managed the gaps between gears manually, a technique called double clutching, where you briefly rev the engine in neutral to match speeds before engaging the next gear. It worked, but it required extraordinary skill, and it destroyed transmissions when drivers got it wrong. There was also a practical ceiling. You could not keep adding gears to a single gearbox without making it enormous and unreliable. The solution came from a company called Spicer, which later became part of Dana Incorporated, and it was elegant in a deeply counterintuitive way. Instead of building one transmission with 18 gears, they built 2 smaller transmissions connected in series. A primary box with 4 or 5 speeds, and a secondary box, called a splitter or range box, that could multiply each of those gears into high and low variants. 4 speeds times 2 range positions gives you 8 combinations. 5 speeds with a 3-position splitter gives you something close to 18. The gear selector in a modern truck is not choosing from a sequential list of 18 positions. It is coordinating 2 separate systems simultaneously, which is why the shifter pattern looks like a cryptic diagram, and why learning to drive a semi takes months rather than days. This same principle of using a mechanical ratio to match 2 systems operating at incompatible speeds is hiding everywhere around you. When the gears on a clock are doing it, keeping a second hand and an hour hand synchronized from the same spring. A bicycle derailleur does it, letting your legs spin at a comfortable cadence whether you are on gravel or pavement. A cordless drill does it. You can feel it click into low gear when you switch from drilling to driving screws. An electric can opener does it, converting a small motor spinning at thousands of revolutions per minute into the slow, steady torque that cuts through steel. Every time you use a hand mixer in the kitchen, the gearing between the motor and the beaters is doing exactly what an 18-speed gearbox does, just at a scale small enough to hold in one hand. When a dentist's drill spins at over 300,000 revolutions per minute, it gets there through a turbine and gear system that amplifies motor speed the same way a truck transmission amplifies wheel torque, only in reverse. Even the spinning drum of a washing machine is geared down from its motor, because if the drum ran at motor speed, your clothes would disintegrate in the first 30 seconds. The honest limit of this system is that it only works because a human is making hundreds of small decisions every hour. Automated manual transmissions have existed for decades, and they do a reasonable job, but a skilled driver reading road conditions, weather, gradient, and load distribution can keep an engine in its efficiency window in ways no algorithm yet matches perfectly. The flip side of that is brutal. A driver who misjudges a shift on a downgrade and lets the engine overspeed can destroy a transmission worth $15,000 in under a minute. The margin for error in a loaded truck going downhill is small enough that trucking schools spend more time on downhill gear management than on almost any other skill. The 18 gears that give a truck its extraordinary capability are also the 18 ways to make a catastrophic mistake. And if you think the gearbox of a semi-truck is fascinating, wait until you find out why the tires that carry all that weight are designed to fail in a very specific and deliberate way.